Alright, in this example, we're going to be looking at solving a trig equation, and this time we're going to have to find the general solutions instead of specific solutions. So first thing we notice is that we have cosine of 2 theta equals negative 1/2. Remember that cosine in the unit circle is x. And so the first thing we need to do is to find all of the angles in the unit circle that have an x coordinate of negative 1/2. And so we're going to pull up our handy dandy unit circle, and we can see that x is going to be negative 1/2 at 2 pi over 3 and at 4 pi over 3. So those are the two angles in the unit circle where x is negative 1/2, 2 pi over 3 and 4 pi over 3. So in this case, we know that 2 theta is going to equal to 2 pi over 3, and 2 theta is going to also equal to 4 pi over 3. Now let's go back to the unit circle for just a second and notice that at 2 pi over 3 we're at negative 1/2. If I were to rotate a full circle, I would return back to negative 1/2. So if I go 2 pi radians, I'm going to always end up back at this x coordinate. So what that means is, it means that I can continue to rotate around this circle an infinite number of times, forward or backward, and always arrive at this 2 pi over 3 angle where x is negative 1/2. So how does that look in general solutions? That means that we're going to arrive at 2 pi over 3 if we add 2 pi times any integer value. So if I rotate one circle, two circle, three circle, or go backward 1, 2, 3 circles, this is the way you describe rotating around the unit circle and arriving back at this angle an infinite number of times. And the same goes for the 4 pi over 3. We can arrive at that angle by going around the circle an infinite number of times. Any integer value of 2 pi added or subtracted to 4 pi over 3 is going to get us back to that angle. So these are the general solutions, but notice I don't have theta by itself. So in order to solve for theta, to know what theta is, I'm going to have to divide both of these equations through by 2. So we're going to divide by 2, we're going to divide by 2, and divide by 2. And so that's going to give us theta equals, and these 2's will cancel, so that's going to be pi over 3 plus pi k. And if I do the other solution, divide through by 2, that's going to give me theta equals, here 2 goes into 4 2 times, so that'll be 2 pi over 3 plus, and these 2's cancel, leaves me pi k. And so now these would be the general solutions, so that no matter what k is, remember that k has to be an integer. This is the way you say k is any integer value. You're going to be able to generate an infinite number of solutions. These are the general solutions. And so what I would like to do now is I would like to go to DESMOS and prove this. So we're going to load up DESMOS, and we're going to say, okay, let's graph the equation y equals cosine of 2x. And you can see that this wave is going to go let's see if I drag that over. There we go. And zoom in or out, we can see that that wave's going to go forever in both directions. All right, next, going back to my problem, we see that we want the cosine of 2 theta to equal negative 1/2. So if I go back here and I say y equals negative 1/2, every one of these dots where the graph intersects, let me zoom in and see if I can zoom in on that. Yeah, there we go. So we can see at pi over 3, 2 pi over 3, 4 pi over 3, and if I keep going, it's just going to be an infinite number of angles. Yeah, but I want you to notice that the first two, there they are, pi over 3 and 2 pi over 3, is what we have in our formula here, pi over 3 and 2 pi over 3. Now what I want to do using DESMOS is something really cool. I want to show you that these formulas actually do generate an infinite number of solutions. So remember, in our formula, theta is x. Yeah, so watch this magic here. So what we're going to do is we're going to say, okay, I want to graph the ordered pair, and my formula is 3 pi plus pi k. Let's see, back to DESMOS. What did I say? Pi over 3 plus pi k. So let's go pi over 3 plus pi, and then we need a k. And it's going to ask, do I want to make k a slider? And I do want to do that. And then I'm going to go back in to my ordered pair, if it'll let me. Here we go. And I'm going to put comma. Now remember this, I want to plot this ordered pair. The pi over 3 plus pi k, that's the x coordinate. The y is what it equals to. So the y is always going to be -1/2. And so we're going to say -1/2. Oh, and I need to change this k here. So let's say that k is going to step from, I don't know, let's say -2. Let's go to 6 and step by 1, enter. And if I change this k to 0, you'll see that that gives me my first solution there. Come on, graph. First solution there at the intersection point. And then if I go, what if k is 1, it jumps to the next one. And then if I go, well, what if k is 2, 3? And do you see it's hitting all of those intersection points? Even if I go negative, -1, -2, it hits all those intersection points. So what that does is that verifies that my formula is correct, because plotting that ordered pair lands at the intersection of these two graphs. All right, so let's do one more. And is it possible to drag him up? Yeah, there we go. All right, so now let's plot, come on, plot another ordered pair. And this one is going to be 2 pi over 3 plus pi k, need a k, comma, -1/2. And you're going to notice that this ordered pair is going to show up as a black dot. The other one was showing up as a green dot. And if you notice, k is 0. So that's going to give me my first set of intersections right here. The pi over 3, let's see if I click on that. Oh, it'll show it. Okay, pi over 3. And if I click on this one, it's not showing the 2 pi over 3. Is there a way to show that? Bam, come on. Nope, not going to show it. All right, but what I can do is I can verify that these points are going to work, because if I go to where k is 1, I've got those two. If I go k is 2, I've got those two. So do you see it's given me those intersection points all along the graph? Yeah, so what that does is that verifies my handwritten work as far as stating that theta can be pi over 3 plus pi k, or theta can be 2 pi over 3 plus pi k. In both cases, this trig function is going to have a y value of -1/2.